Okay. Okay. The next question that we got on the menu today is asking for the laws of inertia, definition, and formula. So the law of inertia kind of comes from our good old friend Isaac Newton and Newton's first law. Was this the first law that Newton never followed? Yes. But it probably wasn't the first law that he ever wrote, but it was the first one that he ever followed. He followed it before he wrote it, believe it or not. Yeah. So what Newton's first law basically is, it states that objects at rest tend to stay at rest. Tend to stay at rest. Objects in motion tend to stay in motion. The only way to change the motion of something is with a force. You can only change motion of objects with forces. And inertia is how much something is affected by a force. Is how much something is affected by forces. Okay, so let's say we have a gust of wind. You know, sometimes there are windy days, and we can feel that the wind does apply a force, right? The motion of the air itself, it does apply a force. I mean, ask any flag or any wind turbine, they'll tell you, like, yeah, wind definitely has a force. But think about, like, how things respond to that force of the wind. If we have, like, you know, a flag waving in the air, the wind is going to affect the motion of the flag a lot. Lots of wind, well, lots of flag motion. But you think about something like a brick. You know, a brick, you can have a lot of wind that goes onto a brick, and it's not really going to move. It has a lot more inertia. So another way that we can kind of say inertia is mass. Inertia are tightly related. Okay, so like in the example that we just had with wind, wind would be like a constant force. It would always be the same, but the way that different things respond to it, well, heavier things are going to be more resistant to the impact of wind, and lighter things with less inertia, things with less mass, things that weigh less, are going to be more affected by a force like a wind. Okay, so yeah, and it also kind of goes into Newton's second law, which is like the magnitude of the acceleration, because force always causes acceleration. So Newton's second law. Pretty much Newton's second law is force equals mass times acceleration. So that's force. This is mass slash inertia. A is acceleration. Well, for this to be true, like more with a constant force, more mass means it has to have less acceleration. Less acceleration means, well, the motion is not going to change as much. The acceleration is what defines how the motion of the object is going to be. Okay, so is there necessarily an easy formula that's all, or a lot of anytime you see inertia, you should kind of be thinking about mass, because they are very tightly related, and all equations and laws that are involved with mass are also kind of de facto related to inertia as well, because of the mass and inertia relationship. Okay. So, yeah. Another way that you can kind of keep this in your mind is like inertia. You think about the word inert, like not trying to move. So more inertia, I'm more inert. I'm trying to move less and less. Or it's not necessarily just things at rest as well. Like, would you rather consider trying to stop or trying to slow down someone riding a bicycle versus a train? Like, a train has a lot more inertia because it has a lot more mass. You trying to apply just the force of your push on a train, well, you're probably not going to slow it down at all. You're probably just going to have a very bad day if you try to slow down a train by pushing on it. But for someone like a bicycle rider, with the force of an arm push, you can cause a significant amount of deceleration, because a bike rider has a lot less inertia than a freight train. So it also works not just for like getting things from rest to start moving. It could be like anything that's moving and trying to change the properties of how they're moving, whether it's slowing down or changing directions. All easier when there's less inertia. So the above solution is good, but